Hello friends, let us start with Unit 2, that is Structure of Atom. The rich diversity of chemical behavior of different elements can be traced to differences in the internal structure of the atoms of these elements. So Indian and Greek philosophers around 400 BC were proposing some models of the smallest particle of element, or the smallest particle of matter would be atom. The word atom has been derived from the Greek word atomio, which means uncuttable or indivisible. So these earlier ideas were mere speculations, and there was no way that you could experimentally prove them. So these ideas remained dormant for a very long time, and they were revived by scientists in the 19th century. So atomic theory of matter was first proposed on a firm scientific basis by John Dalton, a British school teacher, in 1808. His theory is called as Dalton's atomic theory. So he regarded atom as the ultimate particle of matter. So in this unit, we start with the experimental observation made by the scientists towards the end of the 19th century. These establish the atoms can further be divided into some subatomic particles, that is protons, electrons and neutrons, a very different concept than what Dalton proposed. So major problems before the scientists at that time were: number one, to account for the stability of atom after the discovery of subatomic particles, that how atoms are stable even if they have positively charged protons, negatively charged electrons and neutral neutrons. To compare the behavior of one element from the other in terms of both physical and chemical properties. To explain the formation of different kind of molecules by combination of different atoms. So how these different atoms come together to form different types of molecules. To understand the origin and nature of characteristic of electromagnetic radiation. Thus how this electromagnetic radiation is, what are the characteristics, to understand these problems. So Dalton's atomic theory was able to explain many of the concepts which were known at that time. One was the law of conservation of mass. So Dalton's theory was very good in explaining these laws. So law of multiple proportion, constant composition were all explained very nicely. But it was known that glass and ebonite, when rubbed with silk or fur, will generate electricity. Dalton's theory could not explain this. Many different kinds of subatomic particles were discovered in the 20th century. However, in this section we'll talk about two particles, that is protons and electrons. Now, discovery of electron. In 1830, Michael Faraday was a scientist who showed that electricity passed through solution of an electrolyte. Chemical reaction occurs at electrode, which results in liberation and deposition of matter at electrodes. He formulated certain laws which we'll study in 12th standard. So Michael Faraday took some solutions which contained ions. When electricity was passed through the electrodes, so we take a vessel, put some electrolyte in it. Electrolyte is a liquid which allows electric current to pass through it. And electrolysis is a process of decomposition of the electrolyte by passing electricity. So Michael Faraday did his experiment and passed electricity through some solutions, and he saw that the substances were decomposed by passing electricity. So particulate nature of electricity was being suggested. An insight into the structure of atom was obtained from experiments on electrical discharge through gases. So we need to know, or we should know, that like charges repel each other and unlike charges they attract each other. So in mid 1850s, many scientists, mainly Faraday, began to study electrical discharge in partially evacuated tubes called as the cathode ray discharge tubes. Now cathode ray discharge tube is made up of glass. So cathode ray tube is made up of glass containing two pieces of metal called as electrodes sealed in it. The electrical discharge through the gases could be observed only at very low pressure and very high voltage. So two things are important here. First thing, you have to remove the air as much as possible to reduce the air pressure in it. So very low pressure and very high potential difference. So the potential difference was in thousands of volt. pressure of different gases could be adjusted by evacuation. When sufficient high voltage is applied across the electrode, current starts flowing through it. A stream of particles moving in the tube from the negative electrode to the positive electrode, and these were called as cathode ray or cathode ray particles. The flow of current from cathode to anode was further checked by making a hole in anode and coating the tube behind anode with a phosphorescent material like zinc sulfide. So we have a tube, on one side we have cathode and other side we have anode, and behind anode we have a phosphorescent material. There is a hole in the anode, so the invisible particles, they were given out from the cathode, they traveled along a straight line, passed through the hole which was present in the anode and reached the other side, and a phosphorescent material called as zinc sulfide started glowing. A bright spot was seen at that time, and it is also seen in a television set. So the result of these experiments are summarized as below. Cathode rays start from cathode and move towards anode. So they start from the cathode, move towards the anode. These rays themselves are not visible. Their behavior can be observed with the help of certain kind of material like phosphorescent or fluorescent material, which glow when they hit these type of material. Television picture tubes or cathode ray tubes and television pictures result due to fluorescence on the TV screen coated with certain fluorescent or phosphorescent material. In the absence of electric or magnetic field, these rays travel in straight line. In presence of electric or magnetic field, their behavior is similar to that expected from a negatively charged particles, and hence they are negatively charged. So we come to know that they are negatively charged by subjecting them to electric and magnetic field. So these type of particles were called as electrons. The characteristic of cathode ray does not depend upon the material of electrodes and the nature of the gas present in the cathode ray tube. So we can conclude that electrons are a basic constituent of all the atoms. So all the atoms contains electron because electrons are present in all gases. This is what we come to know, because doesn't matter which gas you take, doesn't matter which electrode is present at cathode, every time the result will be the same. So charge to mass ratio of electron. So in 1897, a British physicist J.J. Thomson measured the ratio of electric charge to the mass of electron by using cathode ray tube and applying electric and magnetic field perpendicular to each other. So there is a cathode ray tube, electric and magnetic field were perpendicular to each other. And he found out that Thomson argued that the amount of deviation of the particles from the path in presence of electric or magnetic field depends on. So he told us 3 points. The amount that the particles will be deviated depends on which things. Number 1, the magnitude of negative charge on the particle. Greater the magnitude on the particle, greater is the interaction with the electric or magnetic field, and thus greater is the deflection. So magnitude of charge, suppose there is one positive charge or one negative charge, depending on the magnitude. So if the magnitude of charge is more interaction takes place. So if the charge is +2, then more interaction will take place as compared to +1 charge. Mass of the particle, lighter the particle, greater is the deflection. If the particle is very light, it can easily be deflected by the magnetic or electric field. Strength of the field, the strength of electric or magnetic field, the deflection of electron from its original path increases with increase in voltage across the electrode or strength of the magnetic field. So if you have intense field, if you have very strong field, the magnitude of deflection also increases. When only electric field is applied, the electron deviates from the path and hits the cathode ray at a point. Similarly, when only magnetic field is applied, it hits the opposite point. So if you carefully adjust and balance these both fields, you can bring back the electron to follow to the path followed as absence of electric or magnetic field. They hit at a point. By carrying out accurate measurements on amount of deflections observed, Thomson was able to calculate E upon ME. E means charge divided by ME, that is mass of electron, and he got the value as 1.758820 into 10 raised to 11 coulombs per kg, where Me is the mass of the electron in kg and E is the charge on the electron in coulomb. So charge on the electron. So R.A. Millikan, another scientist, he devised a method as oil drop experiment to determine the charge on the electron. So he did the experiments around 1906 to 1914. So he found that the charge on the electron is around minus 1.6 into 10 raised to minus 19 coulomb. The present accepted value of electric charge is exactly minus 1.6022 into 10 raised to minus 19 coulomb. The mass of the electron was determined by combining these results with the Thomson's value, and that came out to be 9.094 into 10 raised to minus 31 kg. Thank you.